Today's lesson, Metamerism. In this lesson, we are going to learn divalent functional groups because metamerism is seen in divalent functional groups, and then we will see some examples. So let's begin. The first point is divalent functional groups. The functional groups having two valencies. Let's see divalent functional groups. Alkyne group, carbon-carbon triple bond is a kind of divalent functional group. Carbonyl group or ketonic group is a kind of divalent functional group. Ether group is a kind of divalent functional group. This is functional group of a secondary amine. It's a kind of divalent functional group. These divalent functional groups are involved in metamerism. So let's see some examples. Now the point is examples. Examples of metamerism. What are metamers? The compounds having same molecular formula, same functional group, but difference in the alkyl groups attached to divalent functional group. These compounds are called metamers, and the phenomenon is known as metamerism. The first example is C6H10. Let's write structural formula of the compounds. C6H10. First compound is CH3, carbon-carbon triple bond, C3H7. This is a structure formula and this is its molecular formula. Its name is 2-hexyne or hex-2-ine. Another isomer is C2H5, carbon-carbon triple bond, C2H5. Its name is hex-3-ine or 3-hexyne. These two compounds are isomers of each other. Here, this is the functional group. The two alkyl groups are here. One is methyl, another one is propyl. But in this compound, on either side of the functional group, the alkyl groups are different from the first one. So the isomers having same molecular formula, same functional group, but different alkyl groups attached to divalent functional group. This is metamerism, and the isomers are metamers. Let's see another example. Now the compound is C5H10O. C5H10O. This is the molecular formula. Now let's write a structure formula. CH3, CO, CH2, CH2, CH3. Its name is pentan 2-on. 1, 2, 3, 4, 5. Pentan 2-on. Let's write another compound. CH3, CH2, CO, CH2, CH3. Its name is 1, 2, 3, 4, 5. Pentan 3-on. Another compound CH3, CO, CH, CH3. Here another CH3. Its name is 1, 2, 3, 4. 3-methyl butan 2-on. Single word. So these compounds are metamers of each other because This is divalent functional group. Here alkyl groups are methyl and propyl, but in this case alkyl groups are ethyl, another ethyl. Its name may be diethyl ketone or pentan 3-one. Another compound, this is functional group. Here alkyl groups are methyl and this is isopropyl. So these compounds are metamers of each other because of the different alkyl groups attached to divalent functional group. Let's see another example. Now the compound is C4H10O. Let's write structure formula of the compounds. C4H10O. The compounds are CH3O C3H7. This is methyl propyl ether. Another compound C2H5O C2H5. Its name is diethyl ether. Let's write another compound CH3O CH3. Here CH3. This is methyl isopropyl ether. These compounds are metamers of each other because this is divalent functional group. Here the alkyl groups are methyl and propyl. Here alkyl groups are ethyl and ethyl, but in this compound alkyl groups are methyl and isopropyl. So the compounds having same functional group but alkyl groups are different attached to divalent functional group. Let's see another example. Now the compound is C4H11 and nitrogen. C4H11 nitrogen. Let's write structure formula of isomers. CH3NH C3H7. Its name is methylpropylamine. Another compound C2H5NH C2H5. This is diethylamine. Ethyl group, ethyl group. Diethylamine. These compounds are metamers of each other because here divalent functional group is secondary amine. This is alkyl group, methyl and propyl, but in this case divalent functional group, this is ethyl and another ethyl. So the compounds having same molecular formula, same functional group, but difference in alkyl groups attached to divalent functional group. These compounds are called metamers and the phenomenon is known as metamerism. This is all about metamerism. Number today. Thank you very much.